Problem 14. Una rolls 6 standard die, and we're trying to find the probability that the number that she rolls multiplied together, so 6 numbers multiplied together, is not divisible by 4. So what does it mean to be not divisible by 4? Well, if it's not divisible by 4, we just subtract it out, right? Because we're trying to find the possibility that it is divisible by 4. So 1 minus it cannot be divisible by 4 would be the answer. So for a number to be multiple by 4, to be divisible by 4, that number has to have 2 2's, because 4 prime factorization is 2 and 2. So you need to have 2 2's in the prime factorization in order for it to be divisible by 4. So what are the cases, right? The first case is that there's no 2's. If there's no 2's, that is in other words, an odd number. So if the number is odd. The second case is that the number's even, but there's only 1 2 in it. And that's because, for instance, 6. 6 is 2 times 3. It's not divisible by 4 because there's only 1 2 in it. You need another 2 for it to be divisible by 4. So the number could be even, but 1 2 only. So these are the two possible cases, and let's solve for both cases. The first case would be pretty easy because it's an odd number. We know odd times odd gives odd, and you can try that out. 3 times 7 is 21, which is odd. So another odd number times odd gives another odd number, and you see like this is a cascading event. So odds multiplied together were never given even. Therefore, we can have the possible cases of in a die. So die will be equal to 1 2 3 4 5 6, and the possibility that it's odd will be equal to 3 over 6, and the 3 comes from the possibilities of 1, 3, and 5, which becomes 1/2. So the possibility of it being odd will be 1/2, and all 6 die need to be half, so to the 6th power. Now what about this even case? Now even case, there's permutation, and why is that? Let's have 6 die right here, and what are the possible even numbers that provides 1 2 but not another 2? So obviously 2 works. 4 doesn't work because 4 provides 2 2's, but we know that 6 works as well because I just showed you earlier. So the only possible cases where I contribute a 1 2 and still maintain the number's evenness is 2 and 6. So in other words, the probability that it's even, but there's only 1 2 in it, is equal to 2 over 6, and 2 comes from 2 or 6, and that's 1/3. And you can see that works, right? Because an even times an odd gives an even, and that goes on and on with more odds. So that means 2 and 6 are the only possible cases for this second case. Now, what if that number shows up in this die? If that number shows up in this die, it's the same as that number showing up in this die, or this die, or this die, and you get the idea. So that means of the 6 die, 6 pick 1 needs to have, that even number in it. It doesn't matter which one, but you have to consider all cases. So 6 pick 1 would be the total permutations multiplied by the probability of it happening, which is getting a even number, but having 1 2 in it, which is 1/3 to the 1st power. And then that's times by 5 pick 5 of the rest, which is 1/2 to the 5th power. So yeah, so previous AMC questions have actually tested this concept before, but if you don't understand it, just try to think about it, right? Because 6 die, one of them needs to be even. It doesn't matter which one, but if that die shows up here and instead it got moved here, that's still the same combination, but it's another permutation of the same arrangement. So 6 pick 1 will account for that, multiplied by 1/3 to the 1st power, because one die needs to satisfy that condition. Multiply by 5 pick 5 times 1/2 to the 5th, because the other 5 die needs to be odd. So if we multiply this out, that's 6 times 1/3 times 1/2 to the 5th power, which is just 4 times 4 times 2, which is 32. So 1 over 32, which gives 2 divided by 32, which is 1 over 16. And now 1 over 16, we also know that this needs to be summed with the case of 1/2 to the 6th power. So we know 1/2 to the 6th power, 2 to the 6th, is just 4 to the 3rd, which is 64. So that's 1 over 64. Multiply by 4, this gives 5 over 64, and 1 minus that would be our answer, which gives, so 5, so 59 over 64, bringing us to answer choice C, not D, because if you did not consider, this case, then you would have got it wrong, but C is our final answer, which is the correct one, because you considered the permutation correctly.